Hello and welcome to this Follow the Wire video for our OEM customers and partners. In this session, we're going to discuss the benefits customers can get by using fiber channel HBAs with port isolated architecture design. I/O infrastructure is often overlooked, and yet it's a critical element in the on-prem data center. Data center architects and administrators are focused on deploying technologies that deliver highly reliable, secure, and predictable performance. The I/O infrastructure plays a key role in all these areas. And for most of these situations, architects leverage fiber channel storage networking to best meet these requirements. Additionally, downtime and variations in performance are things that simply can't be tolerated in business or mission-critical environments. The question is, how can you ensure predictable performance with fiber channel infrastructure? Well, it starts with the architecture within the HBA you choose. Today, there are two major fiber channel suppliers with two very different design architectures. The port isolation architecture shown on the top here is used in Marvell QLogic fiber channel HBAs, and this provides dedicated processor, memory, and firmware resources for each port on the adapter. This approach ensures that issues that occur on one port do not impact the resources being applied to the other port because they're isolated. While this is a more complex design, this approach does provide full isolation between the ports and thus very predictable per port performance. Now, the shared architecture used by the other HBA vendor, shown on the bottom here, is very different. In this approach, it utilizes an ASIC design that shares the processor, memory, and driver resources across all the ports on the adapter. Now, this is a less complex and less costly design to manufacture, and one advantage of this shared architecture approach is that for a single port environment, there's much more processor and memory resources available, so it can deliver really good single port performance. But that's about the only advantage offered by this design. The key challenge in the shared architecture is that when issues arise on one port, the shared resources, the memory, the processor, and the driver, are used to address this issue, and this could limit the available resources for use by the other ports on the adapter. So which approach is better? Now, the key issue is port performance is not predictable on the shared architecture design. As I mentioned, the issues on one port can affect the performance on the other. Now, that's not the case with QLogic adapters. They leverage the isolated design, and with completely independent ports, the performance of each port on a QLogic HBA is completely isolated from what's potentially happening on other ports. Here's the block diagram for the QLogic 2-port fiber channel ASIC. You can see that each port has a separate processor, firmware, and receive and transmit DMA memory buffers. This completely isolates the two ports and ensures that they both operate independently and deliver predictable per-port performance. Now, here's the product brief from Broadcom's website for their latest Emulex HBA offering. It states right under the performance subtitle that the Emulex dynamic multi-core architecture delivers unparalleled performance and the most efficient port utilization with 8 processing cores and 16 threads that dynamically apply ASIC resources to any port that requires them. Now, it validates that their design leverages a central pool of resources that can be applied to any port that needs them. So why does this matter? Well, what if the optical connection in one port is on the verge of failing, and a series of loop initialization primitive or lip requests are flooding that link, also known as a lip storm? And what happens in this architecture? Well, from what the datasheet implies, the shared resources get allocated dynamically to address this issue. And that means that the other ports on the adapter don't have resources, all the resources they would normally have in their normal operations, which can in turn reduce the performance of those ports until the lip issue is resolved on the other port. Suffice it to say, it's not very predictable. For additional details on the Marvell QLogic port isolation design, you can review the port isolation technology brief on the Marvell QLogic webpage at www.marvell.com/QLogic. This will drill down a couple levels on the benefits of this architecture used in all Marvell QLogic HBAs. So here are the key takeaways. Using an HBA, or any I/O device for that matter, that uses a port isolation architecture will deliver more predictable I/O performance than those that use a shared architecture design. The only fiber channel HBAs on the market today that leverage a port isolated architecture are Marvell QLogic HBAs, including the QLogic QLE2600 series and QLE2700 series 16 gig and 32 gig HBAs. Designing your solutions with QLogic HBAs will better meet your customers' need for predictable fiber channel SAN performance. Well, that's it for this video. For more information, go to www.marvell.com/QLogic to find out details on Marvell and QLogic fiber channel HBA technology. And be sure to check out our other Follow the Wire videos on the Marvell YouTube channel. Thanks for your time and attention. Have yourself a wonderful rest of your day.